Hello, everyone. Today I will show you how to disassemble UHD television and troubleshooting the power supply of this television. So now we disassemble this television. The model of this television is 49UJ634V. So this is the model of this television. So now disassemble this television and troubleshoot the power supply. UHD television, we have different parts. Here we have the power supply. Here we have the main board and the TCOM boards. Here we have the Wi-Fi modules. Here we have the LVDS cable, which is transport the information from the main board to the display control. So the functions of this board is, first, the function of the power supply, prepare the different voltages and supply for the main board and the backlights. So in this power supply, we have different sections we'll discuss in detail. And in the main board also we have a TCON and main boards. This is to process the information coming from the external sources. For example, here is AV source, USB source, HDMI sources. So the information coming from this source to the main board and processed by the CPU IC, which is found in the main board, and transfer for the main display control boards by the help of the LVDS cable. So in today's discussion, we'll discuss in detail in the power supply. In the other lesson, we'll discuss in the main board. For today's lesson, focus on the power supply board. Now, disassemble the power boards. Okay, in the power supply, we have a protection circuit here. The input voltage supplied by these pointers, and we'll go to this port. In this section, we have a protection circuit. Here is a capacitor, inductor. This is help us to remove electromagnetic interference from the power supply and to protect the circuit. This is a fuse that protects overcurrent in the circuits. Here is a VDR or MOV that is protect the circuit from high voltages. It is voltage protection. Here is a current protection. Here is also a booster circuit here to boost the voltage from low level to high level and make efficient power for the television. Here is a transistor STR, which is included in the FVC, PFC circuit, and his chopper transformer that out the voltage from this section or this primary section to the secondary sections. Here is also a rectifier diode that rectify the output voltage from the chopper transformer and transfer for the filter capacitor and for the output pointers. So now we'll discuss the main testing points of this power supply. So now I will adjust my multimeter in the continuity mode and I will show you the main testing pointers without power, that is a cold test, and then we'll give the power and check the voltage. Okay, the voltage here in our country standard 220 voltage until 240 voltage, and transfer this voltage directly to the bridge rectifiers. So in the bridge rectifier supply also 220 AC voltage, and then this voltage rectified by the help of this bridge rectifier. Here is a bridge rectifier. So this is in the AC form, that is convert the incoming AC voltage into DC voltage. So now I'll show you only the line of the current flow. So here is the minus sign. This is connected to the main filter capacitor, minus sign here. All ground points of this section connected to these points. This one is the positive output pointers. This is this direction. Here is a diode. This is bypass diode. Here is also a diode. This is also bypass diode. And for the main filter capacitor, this one is main filter capacitor. In our standby mode, our television, we get 310 or 300 voltages here, depending on the incoming voltage in the sources. So this line transfer to the PFC IC. Here is a PFC IC. PFC IC is used to develop high power for the television in all times. So here is series connector surface mounted resistor. By this resistor drop the voltage and will supply line voltage for the PFC IC pin number 1. This one is the one pointers, critical pointers for checking the voltages. So look, the other point is here. Before the bridge rectifier, we get two surface mounted diode here. This also rectify the incoming AC voltage. The line of AC voltage connected this one. This point also connected this one. And this diode rectify the incoming AC voltage and transfer for the multi IC. These pointers. Here is surface mounted resistor also. Here is the input. This is pin number 80, line voltage. The other point also by the help of this surface mounted resistor, which is connected in series, pin number 1. So in standby mode status is by these 2 points. When supply these 2 voltages, our multi-IC start working minimum. So in this case, this multi-IC out the voltage in pin number 16. This is connected to this one, and for the switching transistor, this transistor is multi-switching transistors, a switch and make the frequency and transfer for the chopper transformer here. So now this chopper transformer will transfer the voltage from the primary side to the secondary sides. So this is the primary sides of the transformer. Here is the secondary parts of or turns of the transformer. So from the primary to secondary, transfer the electric current by the help of magnetic flux. So in the secondary turn now we get the voltages. So this voltage, this point transfer for this point. Here is a jumper, here is a diode, here is no transistors, and then out by these pointers we get the voltage here, standby voltage. In this model television we get 7.8 voltage. So now our television is in standby mode. We see a red color in the bottom side of our television that indicates the status of television. So when you press the power on button on the remote or in the buttons which is found in the television, the power on signal transfer from these pointers to the main board and the main board to the power boards. So in the power board we get the power on signals. Here we have a point that is a main plate for indication of this connection. Here is the power on pointers. This indicate for these pointers because this direction for this one, this pointers for these directions. So this power on indicate the point of this one. So the incoming power on signal connected to this terminal points. So when you press the power on signal from the remote, that signal coming these pointers and transfer for the primary sides by the help of photocoupler. Here is the line, and we get the resistor here. After the resistor we get transistor by the help of this transistor for the autocoupler. So in the secondary side of autocoupler connected with the transistor, here is autocoupler that is behind this surface mounted transistor. So this is the base of this transistor because there is a diode, Zener diode here, this one. So the Zener diode connected with the transistor base terminal, and the VCC will receive the voltage, VCC voltage, that indicate the series transistor regulators. So this is the base pointers. The other points of the autocoupler also by this resistor. These points. So this point is the VCC point for these transistors. So the VCC voltage coming from these directions by the help of this diode. When makes a frequency in the standby mode in these points of transformer, also build the voltage, DC voltage by this diode, and this voltage for the multi-IC VCC voltage. Multi-IC VCC voltage pin number 2. So this is connected to these resistors passing by this line, and we get this resistor. After this resistor, multi-IC pin number 2 in standby mode status. So also this transistor receive these voltages and will make constant voltage in the emitter side. This is a base collector, here is emitter. So this emitter makes VCC voltage for PFC IC here. This is a PFC IC. Also power on signal feedback for multi-IC. Multi-IC pin number 9 and VCC voltage for PFC pin number 8. So now I will show you the line of this one. Here is a diode, surface mounted diode, and also this line pass by this way. The line is inside the surface mounted resistor, and with this resistor, this IC pin number 8. The pin starting count from this one, pin 1, pin 2, pin 3, pin 4, pin 5, 6, 7, 8. This one is pin number 8. So this PFC IC gate the VCC voltage. And also this line also connected to the pin number 9 in the multi-IC. Here is a diode. Here is a resistor. After resistor, direct to gate the pin number 9 of this multi-IC. So now our TV start working. So now there is high voltage in the pin number 16, and we get voltage in the pin number 11, that is VGL voltage and VGH voltage in the pin number 16, and we get this switching transistor high voltage and makes high frequency and to supply for this transformer. So now this transformer transfer the frequency or the AC signal from the primary to the secondary, and we'll get the secondary voltage here rectified by the help of this diode, and we'll get 30.2 voltage. So now this voltage also go to the backlight drive IC. Here is a backlight drive IC. For the backlight drive IC, get the VCC voltage from these pointers. Pin number 2. So now this PFC IC out the signal from this pin number 4, and for these transistors, after this transistor out by these pointers, and we get the minus sign of backlight. Here is LED minus, here is LED plus. So now we get high voltage in these pointers from 190 up to 150.